Okay, so last time we were discussing about Cauchy sequences, right? And definition is clear. What is a Cauchy sequence?
Yes, sir.
So what we were discussing last time? Cauchy sequence. Right, and what is Cauchy sequence? A sequence xn is said to be Cauchy if given any epsilon there exists k. So there exists k such that so there exists case such that xn minus xm is less than epsilon for all mn greater equal k. So this is a definition we saw, right? That means given any epsilon, there exists k onward, all the terms are in this epsilon distance from each other, right? So we also saw that if xn is a convergent sequence of real numbers, then it is Cauchy. So if xn is convergent, then sequence xn is Cauchy, right? So we proved this yesterday. Yes.
Yes.
Okay. And so is converse true? So converse is also true if xn is a Cauchy sequence of real numbers, then it is convergent. So if xn is a Cauchy sequence of real numbers, then it is convergent. Right, so Cauchy implies convergence. So proof will not discuss proof immediately. We'll see this later on. But it is true that if sequence is Cauchy, then it is convergent for real numbers. Right, for real numbers. So note that in general, Cauchy sequence may not be convergent. So in general, if your sequence is Cauchy, it may not be convergent. In general means in general set, right? But in case of if you consider whole set of real numbers, and in set of real numbers, if you take any Cauchy sequence, it is convergent. And then why this is so? Why this is so in case of numbers? Every Cauchy sequence is
So your voice is not audible.
Is it audible?
No, sir.
Sir, its volume is less. The volume of your volume is less, very less.
Am I audible now?
Yes, sir.
Okay. Okay, so what is completeness property of real numbers?
Sir, excuse me, sir.
Yes.
Could you explain from a little bit before because I didn't hear anything?
So every Cauchy sequence is convergent in case of real numbers. And why in case of real numbers? So the uh, uh, in general this is not true. The Cauchy sequence may not be convergent, right? And it is true for real numbers because real numbers satisfy completeness property. So what is the completeness property of real numbers?
So your voice is still low.
Is it clear now?
Yes, sir.
Huh. So what is completeness property of real numbers? Yes. What is completeness property of real numbers? Don't remember what is completeness property of real numbers.
Your voice is breaking. So can you repeat?
What is completeness property of real numbers?
Sir, it is if a non-empty set of real numbers has an upper bound, then it has a supremum.
Right. If set of real numbers is non-empty and bounded above, it has a supremum in real numbers. If set is non-empty and bounded below, it has infimum in real numbers.
Yes.
because of this property, every Cauchy sequence is convergent, right? So I can give you example of a set or space 0 1 interval. What is this? Those real numbers which are lies in between 0 and 1. Then uh, if I take sequence xn is equal to 1 by n, right? Then is xn belongs to x for all n? Is this sequence in set x, right?
Yes, sir.
Right. Second question is xn Cauchy?
Yes, sir.
Right. So sequence xn is Cauchy. Now next question, does xn converge in set x? What is
No,
the
sir.
limit of no, right? So this
Sir,
x,
in set X, it should be X less than or equal to 1.
no. I am taking set open interval 0 to 1. I am not including 0 and 1. So this sequence, right? For each
Sir,
n,
then the first term won't be in set.
no matter, doesn't matter. It is not an issue. I will start from 2 to infinity, right? It is just sequence, and if you neglect first few term, that is not an issue, right? So let us say n greater equal to, or if you still want n greater equal 1, then consider sequence 1 upon n plus 1. Consider sequence 1 upon n plus 1. Then no problem. This sequence is in x. It is Cauchy sequence, but it converges to 0, which is not inside x. So therefore, what is the point here? Xn is a Cauchy sequence in set x, but does not converge in x. That means it may happen that in some set sequence is Cauchy, but it is not converging to that set. And but in case of real numbers, you take any Cauchy sequence of real numbers, it converges inside real numbers, right? That is what the meaning is. Case of in general, it may not be true, right? The property, because this 0 1 set 0 1 is not a complete in some sense. Criteria is equivalent or characterization of completeness or complete sets or complete structures. Okay, that is not important at this moment. Only thing is, in case of real numbers, only point is a sequence xn of real numbers is convergent if and only if it is Cauchy. So in case of real numbers, Cauchy and convergence is actually same. There is no difference if you consider whole set of real numbers, right? Now we'll discuss some examples which help us this criteria to understand convergence of some sequences. So let xn is equal to 1 plus 1 by 2 plus 1 by 3 plus 1 by n, right? Now x1 is 1, right? First term, what is x2?
3/2.
Right. What is x3? 1 plus 1 by 2 plus 1 by 3. Right. So in this way xn. Now what are the properties of this sequence? So xn is monotonic
Increasing.
increasing. Right. So that means xn is less than or equal to xn plus 1 for all n. Now second question could be, is it convergent? Right? Or it's same as, is it bounded above? Right? If it is already it is monotonic increasing. If it is bounded above, then certainly it will converge. Right? And what is another criteria? Is it Cauchy? Because what our result says, if sequence is Cauchy, then it is convergent. Right? So this is equivalent to saying that convergent if and only if Cauchy. What does it mean? Not convergent implies not Cauchy, and not Cauchy implies not convergent. Is it true? Whatever I have written in black color, is it true?
Yes.
Yes, sir.
Right. That means if sequence is not convergent, certainly it is not Cauchy, or if sequence is not Cauchy, then now let us think about this sequence. So now uh, we will check whether this sequence is Cauchy. Right, we will try to check whether this sequence is Cauchy or not. If it is Cauchy, then our previous discussion says that it is convergent. If it is not Cauchy, then also we can say that it is not convergent. Right, and in this case actually it is easy to check whether it is Cauchy. So now consider, let m greater than n, consider xm minus xn. Let us calculate this difference for any m and see, can you make this difference less than epsilon after some k. If at all it is possible, then we can say that it is Cauchy, or not Cauchy also, that we can check. So xm, what is xm? 1 plus 1 by 2 plus 1 by 3. Right, m is greater than n. Suppose m is equal to 15 and n is equal to 10, and I want to write down x15. How will you write down x15? 1 plus 1 by 2 plus 1 by 10, 1 by 11, and so on. So in between 1 by n will be there, 1 by n plus 1 up to 1 by 15, or 1 by m, because m is greater than n, minus xn. What is xn? 1 plus 1 by 2 plus, and so on up to 1 by n only. Right, this is the difference we want to calculate. Now what is difference? Which terms get cancelled? Common things.
Terms between 1 to 1 by n.
Right, so what remains? Up to 1 by m remains, but everything is positive, so no need of absolute value sign. Right, there is no need of absolute value sign because everything is positive. So right, so how many terms are in this summation, last expression? How many terms are in last summation?
M minus
So,
n.
right, total where m, out of them n are deleted, so how many remains? M minus n. Right, and among these terms, which is the smallest term?
1 by n.
1 upon m.
Right, because the denominator is large. So I will replace everything by 1 by m. Right, I will replace this by 1 by m, this by 1 by m, this as it is. So you check that key 1 by n plus 1 is greater equal 1 by m, because m is the larger among these denominators. Right, and therefore 1 by m is therefore whatever this sum we get is smaller sum. Right, so how many times 1 by m?
M minus n.
M minus n times.
So 1 m minus n times 1 by m. Fine. Actually, this is 1 minus n by m or m minus n by m. Fine. So what we have calculated actually, if m is greater than n, then xn minus xm is greater than m minus n upon m. Right. So now our main question is this sequence Cauchy? Is this sequence Cauchy? So now if uh, we choose m greater than n, suppose I choose m is equal to 2n, then is it true that m is greater than n? Is this true?
Yes, sir.
Right, certainly it is true. So if I choose m is equal to 2n, then what is xm minus xn? This difference. This difference is actually m minus n by 2n greater equal, right, by our previous calculations. But I am choosing m is equal to 2 times n. Suppose my n is equal to 10, then I will select m is equal to 20. If my n is equal to 100, then I will select m is equal to 200. In that way, I am selecting m, which is double of n. Then 2n minus n upon, no, what is here? M, so 2n. What is it? N upon 2n, so
By
it is
2.
half. Okay. So what is final step suggest? That means this suggests that for any n, if we choose m is equal to 2n, then xm minus xn is greater than half. Xn minus xm is greater than. Now my question is xn Cauchy? And why? Whatever is your answer and why?
No, sir.
Not Cauchy. Because what definition of Cauchy sequence is? The Cauchy implies for any epsilon there exists k such that xm minus xn is less than epsilon after k. Right, this is the definition of Cauchy. But this fails in this case. Right, what is the negation of this? For every epsilon there exists k. What is the negation?
So if we take
There
epsilon
exists
is equal to half, then
Ah, so
it's
it is
not.
not possible for every epsilon, right? For some epsilon, this expression fails. This condition fails. That means not Cauchy means what? If for some epsilon it fails. What fails? For some epsilon. That is, for some epsilon there is no such k. Right? For every epsilon, if we are able to produce such k, then we say that it is Cauchy. But not Cauchy means for some epsilon this condition fails. That means for some epsilon, that is for some epsilon there is no k means what? There is no k means what?
it is not Cauchy.
No, but mathematically how will you write? There is no such k. For some epsilon, for every k, there is no k means you select any k, that k is not a right k means there are m and n greater than k. So for every k, there exists m and n greater than or equal to k such that xm minus xn is not less than, so greater equal epsilon. This is what the meaning of not. Is it clear?
Yes, sir.
Okay, now what is the situation here? For epsilon naught is equal to half, if I choose any k, right? Suppose somebody say that it is Cauchy, but I will give you epsilon is equal to half, and you choose any k, I will give m and n greater than k. For any k, we have m is equal to 2n and n greater than k, xm minus xn by our previous calculation is greater than half. Is it correct? Suppose somebody gives me k is equal to 10, then I will choose n is equal to 11 and m is equal to 22. For these two, m and n, xm minus xn is greater than half. Okay, somebody will give me very large k, right? Someone can give me, will say that okay, take k is equal to 5000, right? If k is equal to 5000, is it the right k? Ki xm minus xn is less than epsilon for all m n greater equal k. Does this imply?
No, sir.
No, because I will choose n is equal to 5000 and m is equal to 10,000, right? 2 times n. Then what is the difference between xm minus xn is greater than half? So no k. Whatever k you give me, I will give you m and n for which it fails. Right? That is what the meaning is. So, and what is the conclusion? What is the conclusion? P for every epsilon there is k and so that fails. That means xn is not Cauchy. And therefore by our previous theorem, not Cauchy implies
Not
Convergent.
convergent.
not convergent. So not Cauchy implies not convergent. So same thing you can apply for this sequence minus 1 raised to n. Then prove that xn is not Cauchy sequence. Just think about this sequence and how will you prove that it is not Cauchy sequence. Now we'll see some a non-trivial example. Let x1 is equal to 1, x2 is equal to 2, and xn is equal to half xn minus 2 plus xn minus 1 for n greater than 2. Right? So this is my sequence. Okay. So what can you say about this sequence? For example, what is x3? What is x3? It is sum of previous two terms and its mean. Right. So what is x3? 1 by 2, 1 plus 2 is 3 by 2. Mean of previous two terms. This is my x3. Can you tell me what is x4? Half x2 plus x3 and you calculate it. So in this way you can get the successive terms. Right. So okay, is it clear? What is xn? What is xm? Correct. Now,
Yes.
Yes, sir.
okay, note this. If a and b are real numbers, and what can you say about a plus b by 2? Is it in between a and b? Mean is always in between them.
Yes, sir.
Right. Therefore, what is x3 is 1 by 2, x2 plus x1. Right. And therefore, can I say that x1 is less than x3 is less than x2? Is it true?
Yes, sir.
Right. What can you say about x4?
Lies between x2 and x3.
Right. But x3 is smaller than x2, therefore x3 is less than x4 is less than x2. Right. So next, what about x5? So x3 less than x5 less than x4 less than x2. Right? This is a situation. Now, can you tell me what you observe from this? What you observe from this? What do you observe from this? What do you observe from this?
Function is not monotonic.
Not monotonic actually, x3 and x5, but x4 is greater than x5. So the pattern is not followed, right? Do you understand?
Yes, sir.
So it is not monotonic, but first observation is what? The all terms are lies in between x1 and x2. But x1 is 1 and x2 is 2. Therefore, all terms lies in between 1 and 2. This is first observation. What is second observation? Is it true? Odd suffixes. Correct? You check this. Odd
Yes, sir.
suffixes. Terms with odd suffixes are increasing. And what about terms with even suffixes?
Decreasing.
Right. Terms with even suffixes are decreasing. Thus, what is the second observation? The subsequence. Right. x2k minus 1 is increasing and subsequence x2k, right, even suffixes is decreasing. This is the simple observation we have from the property of mean of two numbers. Correct. Fine. Now, what is one more observation? What is one more observation? So, x2k minus 1 is monotonic and bounded. Am I right?
Yes, sir.
Yes, sir.
Hence, term with odd suffixes, it is also monotonic, decreasing, so monotonic. And bounded, hence convergent. That is x2k minus 1 and x2k are both convergent. Right, this is what we just easily observe. Right, is it very difficult to observe these things?
No, sir.
No.
Right, very good. So next, but from this we cannot declare that our sequence is convergent. These two subsequences are convergent. From this, can we declare that the original sequence is convergent?
No, sir.
No. By our yesterday's discussion, if these two have same limit, then that may help us, right? If these two subsequences have same limit, then definitely original sequence converges. That is the different story. Anyway. Now, but what guarantees? Now my next question is, what guarantees that if it is Cauchy, then can we say that it is convergent?
Yes, sir.
Yes,
Right.
sir.
So is Xn Cauchy? That is our next question. So now observe this. Right. First observe simple things. What is X3? X3 x3 minus x2. What is x3 minus x2? x3 minus x2. What is x3? 1 by 2 x1 plus x2 minus x2, right? What is it?
Yes, sir.
So what is it? 1 by 2 x1 minus x2. Is it correct?
Yes, sir.
But x1 is 1 and x2 is 2, so it is minus half. Therefore, x3 minus x2, its absolute value is half, or x2 minus x3 is half. Same thing. Now, what is x4 minus x3? Well, you go to the next. So, what is x4 minus x2? So, x4 is half x2 plus x3 minus x3. Am I right? But it is what? Half x2, half x3 minus x2. So, half x2 minus x3. But x2 minus x3 is already half. So, what is it?
1 by 4.
Right. Now I want to generalize this by induction. By induction, what we can say? Can you make some general statement? Is equal to. What should be the general statement? You can just continue this and check
By
that
2 to the power n.
2 to the power. So see, x3 minus x4 or x4 minus x3. So what is it? 2 to the power 2. In previous case, x2 minus x3. So it is 1 upon 2 to the power 1. So smaller is 2, larger is 3, and less by 1. So 2 to the power
N minus 1.
right. For all on n, you check by induction. This is true, no doubt. Right? This is true. N. Now next, uh, suppose if m is greater than n, then look at x m minus xn. Now I want to calculate difference. So the previous expression about difference between xn and xn plus two successive terms. It is about two successive terms. But now I want to see what is the difference between two terms not successive, xm minus xn. Right? Xm, m is some number greater than n, and I want to check this difference. Right? And I am choosing m greater than n. So what is it? What is the smaller? N. N is a smaller. Suppose I want to calculate difference of x10 minus x15. So what I will do? Because I have some information about two successive terms. Right? This is my previous knowledge. I have some information about two successive difference between two successive terms. Now I want to calculate distance between x10 and x15. So how to help this? How to make use of this?
So we can add few terms inside it, like
Uh,
x11 and minus
right.
x11.
Right. So, what is the next to x10, x11 and add and subtract? Then x12 add and subtract, x13 add and subtract, x14, and now we'll reach to 15. Then we'll get all successive terms like this. So, Now n is a smaller, like here n is equal to 10 and m is equal to 15, right? So similar situation. So what I should do now, xn minus xn plus 1 plus xn plus. I will add next. What is next? Minus xn plus 2 plus xn plus 2 and continue this. At the end what I will get? Minus xm minus 1 plus xm minus 1 and ultimately xm, which is the last one. Now I will group in this way, right? I will group in this way, so that last group will be this. This will be plus xm minus 2 and so on. Is it clear? Now apply triangle inequality. Apply triangle inequality. So right, by triangle inequality, okay, is it clear? Whatever I have written is clear.
Yes,
Yes,
sir.
sir.
Very good. So now use the previous knowledge. What is the difference between two successive terms? Yes, what is difference between two successive terms? 1 upon 2 raised to n minus 1. Okay, so what is the difference between these two terms? What is difference between next? What is next?
1 by 2 raised to n.
1 by 2 raised to n and so on. So power of 2 is increasing, and at the end what is power of 2?
1 by 2 raised to m minus 2.
M minus 2. Correct. Are powers of 2. Now which is the least power?
Minus 1.
n minus
Right.
1.
Right. Suppose we have a situation like uh, 1 upon 2 raised to 3, 2 raised to 4 and so on. So 2 raised to 3 is the least power. If I take 2 raised to 3 outside, what I will get? What remains inside? What remains inside?
1 by 2 plus 1 by 2 raised to 2 up to 1 by 2 raised to m minus 2 minus n minus 1.
Right. M minus n uh, plus 1 minus 2, so minus 1, correct? Is it correct?
Yes, sir.
Right. But 1 upon 2 raised to n minus 1, this bracket is a geometric sum, 1 plus r raised to something n minus 1. So what is this sum? 1 minus r raised to n divided by 1 minus r. Right. So r is 1 by 2. So what is this bracket? 1 minus 1 by 2 raised to m minus n divided by 1 minus half, because r is half in this case. So 1 upon 2 raised to n minus 1. 1 minus half is half. Half, if you shift it to numerator, into 1 minus 1 by 2 raised to m minus n. And m is greater than n, so this power is positive. Now, this bracket 1 minus 1 by 2 raised to m minus n is less than 1, because we are subtracting something from 1. So is it less than? Is it true?
Yes, sir.
Yes, sir.
Ultimately, what we have achieved, thus, for m greater than n, xm minus xn is less than 1 upon 2 raised to n minus 2. This is what we have achieved. Now, can you make this less than epsilon? What is the k for epsilon? Therefore, given epsilon. Now, can you guess what is delta k? So, xm minus xn is less than epsilon if 1 upon 2 raised to n minus 2 is less than epsilon. That is if what? 1 upon epsilon is less than 2 raised to n minus 2. That is if n minus 2 into log 2 is greater than log of 1 by epsilon. Am I right? That is if n is greater than 2 plus log of 1 by epsilon divided by log 2. So what is the choice for k? Can you tell me choice?
Greater than 2 plus log of 1 by epsilon upon log of 2.
Choose k greater than 2 plus log of 1 by epsilon divided by log 2. So on right hand side everything is known. Epsilon is given, suppose, and then 2 plus log 2. So everything can be calculated, and choose natural number greater than that. Then if m is greater than n is greater equal k, then what? For such, if m is equal to n, not an issue. One of them is bigger, another is smaller. So whichever is bigger doesn't matter. So xn, by our previous discussion, it is less than 2 raised to n minus 2, and this is less than epsilon because we have chosen n greater than k. Right? If you choose n greater than this number, certainly this amount is. So therefore, xn is Cauchy. Right, so proof is clear. Xn is Cauchy. Proof is lengthy, but we have used very elementary or simple steps. Right. Hence, we declare that Xn is convergent. Right, but now we can think about what is limit. That could be next question, right? If we are saying that it is convergent, but then what is limit? Right? So Xn is convergent since Xn is convergent. Its every subsequence converges to the same limit, right? Right, whatever I have written is clear,
Yes, sir.
Yes, sir.
right? Because we have proved that sequence, we are sure that sequence is convergent, and by our previous knowledge every subsequence converges to the same number. So that is if limit of xn is alpha, then limit as k tends to infinity x2k plus 1 is also alpha. Whatever subsequence you take, the limit is same alpha. If I take subsequence with odd suffixes, then also limit is alpha. And limit as k tends to infinity x to k is also alpha, or any other. These are two special for us at this instant. Not only these two, so you choose any two subsequence, any subsequence, limit is same alpha. Now, can you find? Now, so if you know limit, if you are sure that sequence is convergent, and if you know that limit of some if you know limit of some subsequence, right? So note that if uh, xn is convergent and limit of xn k some subsequence is alpha, then what is limit of xn original sequence?
Alpha.
Alpha, no choice. Because when we are sure that sequence is convergent, every subsequence converges to the same number. And if you know limit of some subsequence which is alpha, then limit of sequence. So this is what the strategy. Now we'll try to find limit of some subsequence, that will be limit of original sequence. because directly finding limit of original sequence is a difficult task. So observe that. What is x3? What is x3? What is x1? X1 is 1. What is x3? Half x1 plus x2, which is 3 by 2. 3 by 2 means what it is? 1 plus 1 by 2. Right? What is x5? X5 is half x3 plus x4. And I am looking at odd suffixes only. And you check that it is 1 plus 1 by 2 plus 1 by 2 2 to the power 3. You check this. Right. You check this. Check this. So by induction, we can prove that. Right. So how induction is useful? See, because we need induction at several occasions. So by induction, we prove that x2k plus 1 is actually 1 plus 1 by 2 plus 1 by 2 to the power 3 plus 1 by 2 to the power 2k minus 1. Previous odd suffix or odd number. If it is 2k plus 1, that is x11. 11 is odd, is 1 plus 1 by 2 plus 1 by 2 to the power 3 up to, what is the last number in the x11? The previous odd.
2 raised to 9.
Right, exactly. So this is what the odd suffixes subsequence follow. Right. Similarly, you can tell me what is x13 or x31. You can write it as 1 by 2 plus 1 by 2 to the power 3 and so on 2 to the power 29. You check this. By induction it is true and therefore it is true for all odd suffixes. Fine. Therefore, what is x2k plus 1 by our this 1 plus 1 by 2 plus 1 by 2 to the power 3 plus 1 upon 2 to the power 2k minus 1. But I want to idea 1 plus 1 by 2 plus. So 1 by 2 to the power 3. I will write it as, how should I write? 1 by 4 to the power 1. What is next? What is next? 1 by 2 to the power 5. How will I write it? 1 by 5. How to write 5? 5 is 2 into 2 plus 1. 3 is 2 into 1. What is 3? Plus 1. Right? 3 is 2 into 1 plus 1. So, correct. So, what is 1 upon 2 to the power 5? How will you write it? 2 into 2 plus 1. So, ultimately, what is it? 4 raised to 2. Correct? What I want actually, 1
Sir, can't
upon,
we do it like a geometric sequence?
but the powers are odd, right? 2, then 3, then 5. Powers of 2 are odd. It is not complete geometric sum 1 plus r square. It is like 1
No,
plus,
sir, I was telling that we can take first term separate, then from second term onwards, it is a geometric sequence with first term half and r is equal to 1 by 4.
yeah, that is what I want to write it. So that is what I expect. Okay, you want to say that take half outside. Right? You want to say half outside.
Yes, sir, that way also. Okay.
If you take half outside, then that is easy to see. 1 by 2 into. What is in the bracket? 1 plus 1 by 4 plus 1 by 4 square. Right? And what is last? 1 by 4 raised to something. What is it? If we take 2 into k minus, so k minus 1. Right? And now it is geometric series. So what is it? What is geometric series? 1 plus r square. So 1 minus 1 by 4 raised to k divided by 1 minus 1 by 4. Now let us simplify this. 1 plus 1 by 2. 1 minus 1 by 4. 1 minus 1 by 4. 4 minus 1. So 3 by 4. If we shift it to numerator, 4 by 3. 1 minus 1 by 4 to the power k. Okay, this is x 2k plus 1. Now take limit. So therefore, what is limit as k tends to infinity x 2k plus 1? So limit as k tends to infinity. What is limit? One plus to 2 by 3 into bracket 1 minus 1 by 4 to the power k. Right. What is limit now? What is limit of 1 by 4 as k tends to infinity? Limit of 1 is 1 plus 2 by 3 constant. And what is limit of 1 as it is? And what is limit of 1 by 4 to the power k as k tends to infinity?
0.
0. And therefore, what is
0.
final answer is 3 plus 2 by 3 is 5 by 3. Therefore, limit as k tends to infinity x 2k plus 1 is 5 by 3. So we know limit of some subsequence is 3 by 3. And hence, what is limit of original sequence?
5 by 3.
5 by 3. So correct. This is a very interesting problem in which we use many things. It's a big problem, but we use many things in and it is convergent. Right? You go through this problem once again, then you can understand this idea. Right? So, is it clear?
Yes, sir.
Okay, so we'll stop. We'll stop here. If you have any doubt, you can ask. I think time is already over. So